because we have a fantastic
Right.
additional addition to the schedule. So we had Carolann Quinlan-Smith lined up, and she had some unfortunate house difficulties last week, which we won't go into, but she's able to join us. So if it's okay with everyone else, we'll just find an extra 10 minutes now to give her the opportunity to, well, I'm saying 10 minutes, Carolann, just to let her present her work. Thank you very much, Isabel. I'm sorry to rush you, but obviously now
it's great. But
it's great to have Carolann here, so I'm trying to...
I'm so happy, Carolann, that you made it, really. Welcome.
Okay. So welcome, Carolann. Share your presentation and go.
Well, I'm just gonna figure this out, share screen.
Yes, we can see that. That's great. Thank you.
Okay, thank you. I'm just going to click on the slideshow. Beginning. Okay. Everybody can see that? I'm a newbie with this stuff.
Yes, you're doing great. Go ahead. Well done.
Thank you. And thank you so much, Isabel and Sarah. You've been really accommodating. I did have a flood. I like to say it was a natural disaster, but it was not. It was a faulty washing machine. So the only positive that came out of that experience was that I'm getting a brand new washing machine and some positive feedback to Bose because their noise canceling headphones work really well. My husband couldn't hear that washing machine overflowing for a couple hours. So thank you for being accommodating. Okay, so my name is Carolann Quinlan-Smith. I'm a Canadian registered safety professional here in Ontario, Canada. I work for Workplace Safety and Prevention Services, and we're a not-for-profit organization committed to protecting Ontario workers and businesses. So we are a proud partner in Ontario's occupational health and safety prevention system. We receive partial funding through the Ontario Ministry of Labour, Trades and Skills Development, so the enforcement body here in Ontario. And we've been a trusted health and safety advisor since 1917. We service the manufacturing, agricultural, and the service sectors, and we are the largest health and safety association in Ontario. We support over 170,000 firms. So I'm representing industry today. I am a specialized consultant in machine safety and robotics. So with that, I'm quite familiar with the national and the international standards respecting both machine safety and robotics. I also sit on the ISO, the TC299 committee. That's where I met Sarah and Elena and all the other good folks that are listening today that may be on that committee. So I am familiar with those standards, but also the international and national standards respecting occupational health and safety management systems. So it will be these standards, so the ISO 45001 or the CSA Z1000 that I'll be referring to throughout the presentation to address the human factors associated with human and robot collaboration. And additionally, I've frozen here. Sarah, can you tell me what you're seeing on the screen right now?
I'm seeing your title slide still.
Okay, there we go.
There you go.
For a second. Okay, so in addition to that, so in the absence of specific industry standards or guidelines on how to address the human factors associated with human and robot collaboration that many of you have discussed, I'm going to present some solutions that are within the responsibility, control, or influence of the workplace. So specifically the Canadian Standards Association, it is the CSA Z1003. That is the psychological health and safety in the workplace, prevention, promotion, and guidance to staged implementation. Now, this is a voluntary standard that was commissioned by the Mental Health Commission of Canada and was supported through funding by the Government of Canada, Bell Canada, Great West Life, and Mental Health and Workplace. Also, 2 papers in particular, one on collaborative robotics, assessment of safety functions and feedback from workers, users, and integrators in the province of Quebec. And that is our sister organization in Quebec, the IRSST. And also a paper entitled Consider the Human Work Experience When Integrated Robotics in the Workplace. So in this paper, the authors explored the relationship between work attributes and automation goals by engaging in field research at a manufacturing plant. And that's where primarily most of my experience is, within the manufacturing sector for a very large tier 1 automotive supplier prior to WSPS. So based on this study, they created a set of integration considerations for organizations planning to deploy robotic technology. So very appropriate for today's discussion. Most of you have mentioned the plethora of benefits of collaborative robotics. We know that the robot speed, movement, the lower payload, easier to program, you got fast setup, and a lower price tag. We see a lot of the benefits of collaborative robots. However, the integration of collaborative robots, as we've discussed again throughout the better portion of today, it does invoke many different human experiences. So the speed of the robot, the movement, whether that's planned or unplanned, may cause that stress to the human engaged in collaborative partnership with the robot. In addition to the common and widely publicized fear of job loss, the complete or partial lack of GARs can cause anxiety and fear of a collision and being in close proximity to a robotic colleague, or from the part being handled or the material being handled. The traditional physical measures used to protect operators from the robot's movement and other associated risks have now been replaced with inherently safe design. And these design measures are built right into the robot. So this new advanced technology is unfamiliar for workers and presents a challenge to them, both the experienced and the unexperienced with robotics alike, to trust this efficacy of technology that they can't see or feel. So often the introduction of a robotic colleague into our workspace is often, in my experience in conversations with the very few customers that we have that have utilized collaborative robots within their workplace, it's often sudden and forced upon the human worker who's long been separated by means of those fencing. So this approach commonly results in worker resistance to adopt the technology on the plant floor. And I wish I could provide some names. So there are some very large tier 1 automotive companies that have taken this approach and have been met with resistance and had to try and find a different way of integrating the systems. And that first step is understanding the human factor. So we need to learn to understand also that changes in work tasks or the work environment made without consultation or involvement of a worker can spur resistance. And that can significantly impact the human experience and your overall productivity. Worker participation and consultation is the cornerstone of any health and safety management system. So we're going to dive into how we can make that happen. So an employer we know has that legal and ethical responsibility for health and safety of its workers and those affected by the activities. And this includes protecting a worker's physical safety, and now with a greater concern, and specifically in Canada, a worker's psychological safety. So according to the CSA Z1003, and by the way, that is a free download on the CSA website. It's the definition of psychological safety is the absence of harm and or threat of harm to mental well-being that a worker might experience. So in 2010, the Mental Health Commission of Canada made the request to CSA to develop a standard to improve psychological health and safety in Canadian workplaces. So this national standard for psychological health and safety is the first of its kind. We're pretty proud here in Canada, and it was launched in January 2013. And it's already garnered much attention and uptake from coast to coast and internationally and across all sectors and businesses. And we need to focus on mental health and safety in the workplace, again, in addition to our physical safety. And as quoted by Louise Bradley, President and CEO of the Mental Health Commission of Canada, it's time to start thinking about mental well-being in the same way as we consider physical well-being. And the national standard provides that framework needed to help make this happen. And that framework that can be used in absence of the inclusion of how do we integrate or successfully integrate collaborative robots within the workplace. And that information is not currently contained within 10.2.18 or within our national standard, the CSA Z434 standard for robotics. So this national standard provides a framework for strategic action through, and most of you will be familiar with this, the Plan, Do, Check, Act process. So it's aimed to have a fully integrated strategy that manages potential risks and liabilities related to workplace mental health, promotes the performance and engagement benefits of workplace mental health, and fully leverages a management system framework. The core of the national standard is to focus on the identification, assessment, and control of elements that impact psychological safety and health, and we call these workplace factors. So within the national standard, there are 13 workplace factors relevant to Canadian organizations and employees, whether those organizations are small or large, public, private, not-for-profit sectors that impact workplace mental health. So these factors summarize opportunities for the organization to promote a healthy workplace environment and prevent mental distress on workers and keep them healthier, happier, and more productive. The 13 workplace factors address common workplace and organizational culture issues as listed on this slide. And I'm not going to go into all 13, but these are 13 elements that contribute to a healthy and thriving environment and can lead to a more psychologically safe workplace. So I am going to highlight the specific workplace factors inhibiting collaborative technology acceptance, and just a couple of them. And I'll discuss how a workplace can address each factor during the commissioning process for successful human and robot collaboration. And this kind of lends well to the question prior to me coming on. So keep this in mind. So I'm going to talk about clear leadership, influence, and involvement in protection of physical safety. So clear leadership. Clear leadership and expectation is present in a work environment where there is effective leadership and support that helps employees know what they need to do, how their work contributes to the organization, and whether there are impending changes. Changes like the introduction of a collaborative robotic system. So there are many different types of leaderships, each of which impacts psychological health and safety in different ways. Transformational leaders are seen as change agents and motivate their followers to do more than what's expected. They're concerned with long-term objectives and transmit a sense of mission, vision, and purpose. And we'll touch on that in a bit. They have charisma, give individualized consideration to their employees, stimulate intellectual capabilities in others, and inspire employees. So a workplace that has clear leadership and expectations will be able to state that the staff is informed about important changes at work in a timely manner. The next one is involvement and influence. They're present in a work environment where employers are included in discussions about how the work is done, how important decisions are made. Opportunities for involvement can relate to an employee's specific job, the activities of a team or department, or issues involving the organization as a whole. So when employees feel they have meaningful input into their work, they're more likely to be engaged, have a higher morale, and take pride in their organization. This in turn increases their willingness to make the extra effort when required. Job involvement is associated with increased psychological well-being, enhanced innovation, and organizational commitment. And lastly, protection of physical safety is present in a workplace where management takes appropriate action to protect the physical safety of employees. Employees who perceive the workplace as protective of physical safety will feel more secure and engaged at work. Research has shown that when employees have higher levels of confidence in safety at work, they experience lower rates of psychological distress and mental health problems. The sense of physical safety protection is enhanced by adequate training with regard to physical safety, trust that the employer minimizes physical hazards, and confidence that the employer responds quickly and effectively to things like safety incidents, and the opportunity to have meaningful input into workplace policies, practices, and work organization, work attributes. We're going to talk about that in a minute. So the protection of physical safety is also an important bridge between traditional health and safety and a new era of mental health and safety. Okay, so we're going to talk about clear leadership. So change has become prevalent in the workplace. Organizations need to become more nimble in order to stay competitive in today's marketplace. So failure of these changes can have a significant impact on stakeholders in an organization and the longevity in an organization. So a key factor in the successful outcome of change is to ensure there are clear lines of communication at all levels within the organization and consultation and participation of workers within the change process. So when implementing a change such as the integration of collaborative robot systems, organizations need to convince stakeholders to alter work practices, processes, procedures, work arrangements. They're going to have a new colleague. It's not going to be a human colleague, and often beliefs and values or perceptions. So in change implementation, communication is a means by which an organization can increase a worker's understanding of the reasons for the change and their ability to adapt and adjust during the implementation phase of a change process. Prior to the introduction of a collaborative robot system, with this knowledge, the senior leadership should clearly communicate their intent, their rationale, their goals for the change, as well as the potential impact on roles and specific jobs, their commitment and support throughout the commissioning process, providing the necessary resources, the time away to participate and engage in the process, and solicit worker feedback and participation throughout that commissioning process. That transparent leadership, that open and ongoing dialogue between leadership and workers. And then also allowing them that platform to raise any issues, managing rumors, feelings, concerns about the impending change, job loss, for example. And it will promote that employee engagement. So it's important to allow workers to voice any concerns that they may have about working alongside these collaborative robots. And these concerns may even raise important issues that haven't actually been thought of at the design or the deployment stage of the system, and can make the difference between a successful and a failed deployment of a collaborative robot. Implementation, I mean, it can often compete for time. We always think, production's always first, and sometimes there's that perception that production comes first. So let's have that conversation and make that commitment known to employees that there is going to be an allotment of time and attention and resources that traditionally may have been devoted to other things. Involvement and influence. The numerous studies suggest that early and significant worker involvement in decisions pertaining to changes in the work, it gives them that sense of ownership and control over upcoming changes. And this can be key to a successful outcome. In one study I read, if the operators want the system to work, they try everything they can to ensure it does. Conversely, if they do not feel part of the project and they do not have any ownership over the system, they do not actively support resolution of any problems, instead waiting for others to address the issues. So worker participation by those impacted by the technology should begin in the concept stage of an automation project. Participation from those with knowledge and experience of current production or familiarity with equipment, those that service the equipment, such as maintenance, engineering, and other stakeholders, it's essential, especially if an organization is considering integrating a collaborative robot into an existing system. One case study showed the benefits of having a process champion. So the person who understands the technology and common applications and can cascade this knowledge to the rest of the team. So as the starting point, we suggest the organization should designate an individual tasked with leading workshops where key stakeholders from across the organization can meet to identify some simple processes for automation with a primary focus on identifying tasks that operators maybe dislike and preserving work preferences. So work preferences are important because they link to job performance and long-term success via motivation and satisfaction. So this understanding of work performance or preference, is important because as collaborative industrial technology is considered for integration, work preferences can be targeted for preservation, which can positively affect a worker's psychological health and technology adoption and implementation. Next, relevant data should be gathered by that team that will assist the organization in identifying tasks for which are physically or psychologically demanding. So we're going to look at accident reports, worker feedback, such as discomfort surveys, ergonomic assessments, and claims data. So getting all of that information together to help support your decision to adopt this automation. So following the selection, the next step in that planning process, so we're following that plan, do, check, act, is providing workers with the opportunity to now visualize the job sequence and the degree of human and robot collaboration using computer-generated simulation software, for example. I've had a lot of the robotic manufacturers, they offer this at no charge, and you can actually find the software directly on their website, and I've played around with a few different software packages. So this really provides the visual learner with a better understanding of the technology and the breadth of its capabilities, as well as the limitations, and then easing their fear and anxiety about the proposed new way of working. And alternatively, if not all, robot manufacturers, they do offer demo robots, which give workers an opportunity to gain that hands-on experience for the kinesthetic learner like myself. Get your hands on the technology, and that's how we learn, and that's how we become more comfortable with that new technology prior to bringing that into the workplace. So easing that anxiety. And in the one study performed by the IRSST, the workers overcame their anxiety by testing the stopping of the robot in collision. So they actually got that hands-on. And I know of another local business that approached it in the same manner. Part of their training was to allow the operators to actually get bumped by the robot to ease that fear, that anxiety that they're going to get hurt. Okay, the last one is protection of physical safety. Sarah, how many more minutes do I have? I'm on the home stretch, I swear. I promise.
Well, none really, Carolann, so just go for it.
I'll try and shave it down a little. Okay, so the very last one is protection of physical safety. And can you see let me just turn this little guy on here. There we go. All right. Protection of physical safety. In collaborative robot operations, humans we know work in close proximity to the robot while power is available to the robot actuators. ISO 10-18 and the technical specification for collaborative robots, the TS 15066, it outlines 4 different types of collaborative operations with power and force limiting by design or control causing the greatest concern for physical safety. So in such operations where a human and robot share the same workplace, a key process in the design of the robot system and the associated cell layout is the elimination of hazards and the reduction of risks. So a risk assessment, it is a normative or mandatory requirement in ISO 10218 and a necessary process for determining the appropriate risk reduction measures to ensure operator safety during collaborative operation. Hazard identification is fundamental in the planning process to prioritize actions to address risks and opportunities. A collaborative robot is not inherently safe for system for use in every application. An organization must consider the hazards associated with the entire robotic application, including the robot end effector, which in my experience is often forgotten. We're like, oh, this is great technology, I'm going to implement it here and here. And we forget about the end effector. And we forget about the end effector in the risk assessment process. And based on that study I mentioned, that is a considerable source of anxiety and fear for a worker. What's at the end of the end effector? What is the material? What is the part that's being handled? Could that hurt me? So definitely should be part of that risk assessment process. So a risk assessment enables that systematic analysis and evaluation of risks associated with the robot system, and it should be considered over the whole life cycle from design right through to decommissioning. And according to 10218, the integrator or the company contracted to design and build the system is responsible for carrying out a task-based risk assessment in the design phase to determine the appropriate safeguarding measures and update it as the design matures. It also states the user should be consulted during the hazard identification and risk assessment process to ensure that the integrator has identified all reasonably foreseeable hazards and hazardous situations associated with the robot system. Leadership should ensure the availability of those key stakeholders that I mentioned earlier within the organization to participate in the hazard identification and risk assessment and reduction process. According to the research team at IRSST, getting in workers involved, the integrator will run less of a risk of hindering the performance of workers' tasks by choosing unsuitable means of risk reduction. Changes in technology typically brings forth a change or increased demand for skills, and as such, workers may be reluctant to accept changes if they're anxious about their ability to perform their jobs after the change. So research has shown that adequate training can strengthen a worker's confidence in their abilities to accommodate the workplace change, and it empowers them to learn new skills. To minimize worker resistance to technology adoption generated by fear and anxiety, it's critical that affected workers receive training prior to handing over that fully commissioned system to production. Another way that we can engage our key stakeholders within that commissioning process is the robot system testing and debug at the integrator site. That provides an excellent opportunity to introduce operators to the system, enhancing their knowledge, familiarity, and confidence with the technology. Operator involvement in the final installation on the factory floor is also another means in which we can engage them through that verification and validation process. And I know that Elena touched on that process. So getting involved in that particular process, going through a final buy-off of the system, going back to the risk assessment to determine how we implemented the safeguarding in accordance with the risk assessment. So getting them involved in that. Okay, so in conclusion, we know that collaborative robots are experiencing rapid growth. There's a lot of benefits, decreasing price tag, flexibility, minimal integration cost and time. Organizations seeking to reap the benefits of this technology really need to understand the psychological impact of sharing a workspace with a robot that was once caged for protection. So forcing such change, we know, as I mentioned, can generate fear, anxiety, lack of trust in the technology, which can affect the technology acceptance and adoption. A systematic and structured approach based on a management system model, that Plan, Do, Check, Act, that involves worker consultation and participation in the planning, design, and implementation phases of the robot system, and where leadership is effective and provides sufficient support, communication throughout that robotic commissioning process, will positively affect the human experience and develop and sustain a psychologically healthy and safe workplace. And hopefully future integrations will go seamlessly. That's all I have.
That's fantastic. Thank you, Carolann. You need to lie down now.
That was a fast track. That was the Cole's notes.
That was well done. We're all awake now. We're all buzzing. Thank you. Right. Okay. I'll hand over to the floor. Does anyone have some questions for Carolann? Thank you. That was really practical advice as well. I think we've had a lot of theoretical stuff. We've had a lot of practical work, but this was really good practical advice as well. Isabel.
No, I just want to tell Carolann, great that she made it. It was a great presentation. Thank you.
Thank you.
Okay. Does anyone have a question for Carolann, or has she blinded you with her speed?
I did.
She was running.
Mm-hmm.
I know.
I feel like I ran a marathon there.
I think you did very well. And I just want to say, I've got a question. Okay. How well do organizations, in your experience, appreciate the recommendations you make? What's your biggest challenge, if you like?
Oh, I think the biggest challenge is a really good question. The biggest challenge for them is really understanding, twofold, the technology and the standards respecting collaborative robots, even your traditional industrial robots. So because it's quite technical and comprehensive, it is very much a challenge for them to actually follow the process outlined within the standards. So the 10.2.18, starting with risk assessment and then moving through that process. So that process alone is mind-boggling for them. And then for me to come in and ask questions, and as I mentioned, there are very few organizations that have actually successfully, in my travels, integrated a collaborative system within their workplace. And I should preface that the power and force limiting collaborative applications, speed and separation have traditionally been kind of the norm. And but to start talking about the human factor piece, it's like, but they are typically, if I do approach an organization that has met resistance, they are more open to having the conversation. So I think the standards respecting the design and integration of the systems is overwhelming for them. But then to have flipped that and have the conversation about the human factor side, I don't think at this point, not many are ready to have that conversation. But those, again, that I mentioned that have struggled, there is more of the acceptance. And that's where I can kind of slide in our national standard on psychological health and safety in the workplace as a framework to kind of walk them through. And as well, it's based on health and safety management systems, that Plan, Do, Check, Act, which most organizations have developed a health and safety management system or a quality management system. They're all built on that Plan, Do, Check, Act framework. So that when I approach it from that respect, it's a little bit more palatable and they understand that piece when I walk them through how can we.
I think that's what I found so practical about it, is that you're integrating with existing systems and processes for risk assessment, and so it's not alien to anyone. We're not, it's just you're throwing the word psychological in there, which you want to be careful of.
Yes, yeah.
Only joking. Okay, do we have any more questions for Carolann?
I just wanted to ask something else. I forgot that. Which kind of organizations generally require your consultancy? so far?
Within our organization?
Yes, which kind? Industry, manufacturing, which kind of
Manufacturing.
sorry?
Manufacturing.
Manufacturing. Okay. Thank
Yes.
you.
Yeah. Yeah.
Okay.
I'm seeing them in automotive part suppliers as well as food and beverage.
Okay.
Yeah.
And they have been keen on adapting your guidelines.
Yes. Yes. Yes.
Great.
Because they
Okay.
seem to all have the same challenge. They have this great technology, and they're really interested in this technology. But where do we start? Where do we begin? And that whole planning piece of the Plan, Do, Check, Act, and getting people involved in that process, that active participation by those that actually do the jobs, because it's typically we're integrating a collaborative system within an existing system. So getting those key stakeholders at the table, and let's start talking about, is this the right technology for this particular application? And also, and I've kind of was speeding through that, but there should be active involvement with the manufacturer or the vendor. I've been out to numerous vendors and had conversations, and within their workplace, they have demo models on the floor, and you can have the conversations about, I have this particular application in mind. Can you show me so I can see, some of the systems that you have that may be appropriate, and you get a better understanding. So really having conversations with key stakeholders within the organization and talking about work preferences and whether this technology fits, but also involving the integrators or having them come on site. I was working with one particular automotive, a tier 1 parts supplier, and they brought in a demo robot at no cost. So they were able to integrate that into an application, kind of a try before I buy deal. So they had them in, they provided the training and the instruction, but the conversation first started with them. And then, okay, we think this might be a fit, but let's try it. And then that allows the individuals who are working within that area, or they may operate the equipment, to become more familiar and comfortable before they press the go button. Yeah, you know what? We've been working with this for a few months. It's going to work for us. So.
Oh, that's great. That's great. I think that's the way also AI and the choice of specific algorithms to run now on a different domain, to run in enterprises should this initial assessment of what the organization requires, what are the features of this organization and what can be deployed there, and then test how everything goes on and how the workers react is really fundamental. And I think you do a great work. Congratulations.
Yeah. Thank you.
Thank you so much, Carolann. Thank you, everyone. Thank you, all speakers. I need to close this session on industrial robotics. I'm afraid we're getting lots of hints.
I think Selma is raising the hand.
Oh, Selma, sorry.
Selma.
I'm sorry, if there's no time, I don't need to ask, but yeah.
Go ahead.
No, go ahead, please.
I know the domain is radically different, although automotive parts to automobiles, not exactly light years. We're just charging ahead with cars, and if cars are robots, I think many people in the industry of autonomous driving view cars as robots, and the driver is the collaborator. I wonder if you have any thoughts about the apparent fact that we are, again, just charging ahead, building these things, deploying them. We've already had fatalities. I don't see any of the science you're bringing to bear whatsoever in that industry. My wife's new car, I can drive it for 4 hours on the interstate. It drives essentially by itself, and I'm not trained. I'm not edged. So I wonder if you have any thoughts about this.
Is that question for me?
Yeah, because as I understand it, while your domain is different, you're working in informing and guiding a collaborative relationship between humans and robots, and that's what autonomous vehicles really are so far.
Yes, and unfortunately, I can only speak to the robotics side. Sarah, I don't know within your field of research if you'd probably be more equipped to potentially answer that question. It's a really good question.
It is a really good question, and thanks for passing it to me. We in our research we collaborate with people that are working on autonomous cars or self-driving cars and things like that, but we have viewed them very differently. We haven't viewed cars as robots. We viewed them as machines that humans have full control over. Yeah. So perhaps you're suggesting something that is there to be done. I take your point, but it's not the way we have, certainly in my university and in my awareness that's been done. We have viewed cars as a controllable system, fully controlled by humans.
That's interesting. Yeah, thank you.
Okay.
A little scary, but thank you.
Yeah.
Oh, we're getting there. Okay, I think it's time that I closed and thanked all of the speakers for this wonderful session on industrial robotics.
Yes,
I think it's been a fantastic collection of technical and engineering and human approaches and practitioners and academia. So it's been a really nice collective, eclectic collection, I suppose. So thank you to everyone.
Let's be together. Let's keep together and go forward together.
That's we're all interconnecting. Okay.